I want to know more about SQL indexes because everyone talks about them and nobody really ever explained me why should we use them and how should we use them.
All right. So indexes is a way of making the searches in the database faster. And I think a way that you can visualize it is exactly as an index in a book. And the way it's done is that instead of searching through thousands and thousands of rows to find one specific entry, the database creates an index where a specific row is pointed to a specific, actually a specific entry is pointed to a specific row in the database. So.
Sorry, I was mute. I see a lot of books behind you. Maybe can you show me like how the index of the book looks like?
Do I have one? Sure, one moment. I don't know if they have index because they're literature, so let me see.
Okay.
Probably this one. It does.
Great. Let's see how it is.
So let's say that, so this is a book about animation. Mm-hmm. And let's say that we want to search about Disney animation specifically. So okay. If I only had this in mind, then I would have to search the whole book and this would take me some time. But since there is an index, then I would go here. I don't know if it's visible, probably not because I'm quite small. But then I can see that Disney animation can be found in page 94, for example, for the first time. And then I would go very quickly to page 94 and I would be able to read about Disney animation.
Okay, I think that's really great because this analogy helps me understand that, okay, this is how maybe it works. And what should I do in my database now to understand this better? Because I already have a database, I have MySQL set up. I can probably share my screen with you and maybe you can tell me.
Yeah, well, the first thing that you will need is a very, very big table.
Okay.
Because there's no point in using indexes in smaller tables because they're already quite fast. So you will need maybe a few million of records.
Okay, I'm going to try and create that.
Awesome. Maybe can you share your screen?
Yes. Am I not sharing now?
No.
Okay, so let me see where are these options. I'm looking for the options here, which I cannot find. Okay, there we go.
It doesn't allow you to share your screen?
Ah, it does, I think. Yeah.
All right.
Just took me a while to find it. So now we have it. And so I have this program already, which uses HYF user and password. It connects with the database big, and I will create a table huge. And I will create, I think, this one column that contains, that is a primary key column and it is auto incremented. Okay. And I will create another column that is just a number column. Then I will create a for loop for where I goes from 1 to 1 million. And then after every 10,000 rows, I will add these many rows as a bulk insert into this huge table. And I think, correct me if I'm wrong, but this then will create a table that contains 2 columns with the same values because the IDPK column will be added automatically, correct?
Yes, correct.
So I will run this program and I hope it will create the huge table and then we will look at my database. Okay, let's see. I save this and I run this with node bigdata.js. It's going strong. Okay, it created 1 million records, it seems. Now I will, to MySQL, I will use the database big because we created this table in the big database. And then I will see show tables. I see a huge table over there. And I will basically see if I have inserted that many records. So I will do select count star from huge table, and then it should be the 1 million. So I think I created the table correctly.
Perfect. Can you also show just a few lines from the table,
sure.
just to show the columns?
Yeah. Maybe 10.
Perfect.
Okay, so now what is this deal with index on this table?
So first of all, I think that we need to explain that the basic difference in between these two is that, first of all, yes, the ID column is a primary key, but also we need to explain that the primary key is an index by itself. So it's a way to search the database faster.
Okay.
Maybe you can already show how this is faster by selecting based on an ID.
Okay, so I do select star from huge, and I do something like where ID pk equal to some random number.
Yeah.
1000. And I run this query. Okay, this is very fast.
Of course. And when can you perform the same query, but now with the number instead of the ID?
Okay, so I search with number equal to.
Yeah.
Okay. Oh, wow, it did take longer.
Yeah, you can see that there is quite a difference. So the difference here is the index. The first column, because primary key, there was an index automatically created. And this means that we can immediately find where the row with the number 1000 was. So maybe you could also show the describe queries for this. Just to show how many. Yeah.
To describe, select star from huge where ID underscore pk equal to 1000.
Mm-hmm. Perfect. So here, if you check, the search was done in only one row.
Oh, yes, I see it here. Yeah.
But if you perform the same for the number, you will see that there were a lot more rows accessed in order to give us the result. So the difference is quite big.
Is it because on the number column there is no index and then it has to go through every row?
Yeah, exactly.
Interesting. So can I actually create an index on the number column?
Yes, you can. But I'm not sure if in this video we will do it on this table. Maybe we will need a smaller table to perform the index, because creating an index takes some time.
Okay.
And maybe we want to make it shorter. So maybe let's make a small table to perform this.
Yes. Or, how small? How many?
I think 10,000 or 100,000.
100,000. Okay. So I'm going to edit the same file basically.
Mm-hmm.
And I'm going to say it's a large table with not 1 million, but 100,000 entries.
Mm-hmm.
And I will say large here, insert into the large table.
Exactly. So basically, we don't want it to be as large as the first one, because our create query would be very slow, but we still want it to be large enough so that we can show this example.
Yeah. So I will run this one. And we now have the large table as well, not just the huge. So show tables, I think. We have large table. I will do select count from large, should be 100,000, but there is 200,000 because I already had the table large. So now I'm going to
you can either create a table
drop,
select, or
maybe I will drop this table and just rerun. Yeah, drop table large. Yeah, and then I will just rerun this query, rerun this program. Will create 100,000. Yeah, now we have exactly 100,000 entries, and just to confirm, it will have the same type of values as the huge table with the same numbers in both columns.
All right. So now we want to create an index on I guess the column number now, because the first column already has an index.
Yeah. Shall we also run the queries on this table to show that it is still faster with the index?
Of course.
So let's try this. Select star from large, where id underscore pk equal to some number, and it's very fast. But if I do search with where clause with using the number column, then it takes a bit of time.
Yeah, it seems very small now, but still it's quite a difference.
Yeah.
All right. All right. Okay, so let's see how we create an index. I think that the create index command is actually mapped to alter table, but I think that the easiest way to do it is by creating an index.
Yeah.
You know how to do it?
I think so, but if I make a mistake, tell me. So create index, I will just name something like on number.
Sure.
IDX number. Yeah. On table large. And the column should be number.
Yeah.
So I'm creating the index whose name is IDX number. It's on the table large and it's with on the column number. So it created correctly. Is there a command to show the index as well?
Yes, you should. You can do show indexes on from table from the.
Okay.
From the
so I'll do show indexes from table. Yes, and now here I see. Oh yeah, this is because you were mentioning earlier that primary is also an index. Primary key. So this was automatically created for me.
It's created when you create when you want to add the primary key.
And IDX number is the one that we just created.
Yep. Exactly.
On this column. Okay. And now shall we rerun the query here? So I run again select star from large where number equal to 45667. And now it is indeed faster.
Yeah, it's as fast as the query on the index column. I'm sorry, on the ID column.
The ID column. Let me try and again describe this because I was describing the query before. And now it accesses exactly one row.
Yeah, exactly. So before it was, when you performed this query, it was accessing a lot of rows, but now it's only one, just like when we performed it on the primary key.
Yeah, and I will try the same thing on the IDPK. Yes, exactly. It'll also access exactly one row. So great. So indexes are really helpful in this way when you are accessing a table that contains many records.
Exactly.
Okay, so I understood why we should use index. Is there also a case for not using index?
Yes.
Or like when And when is it a hassle to use index?
Well, first of all, when you have a small table, I mean, there's no reason to add indexes, because then an index demands space on the database, which you don't need to spend when you have small tables. When you don't need to add an index on a column when you know that it won't be used in a lot of joins or in a lot of queries. And you shouldn't add indexes on tables where you know that will get updated very frequently. Either if the values are changed, or if there are new inserts in the table, then the indexes have to be updated as well, and this might need a lot of processing time. Maybe we could show an example for this.
Okay, sure. Yeah, I would like that very much.
Okay, so right here we already have an index on this large table. This is the large table we already have an index both on the primary key, on the ID table, on the ID column, and the number column. Maybe we can try updating one of the columns.
Okay, so I will try to update large and say set ID underscore PK equal to ID underscore PK plus 100,000, because we have records until 100,000. This should work, right?
Yes, this should work.
Okay, it's taking a while. 2 seconds, 2.46 seconds.
Yeah. So now this shows you that because of the index, it took some time to update the column. But in order to show how it would be without the column, we need first to drop the index in the number column.
Oh, because if I'm now correct, then if I update if I write the same update query, but with the number column, then it will be also as slow as this one.
Exactly.
So let me try that. And this is because we have index also on that one.
Yeah, well, it's not exactly the same, but it's close enough.
Yeah, it also took time.
The reason that this takes some time is because we have added indexes here, and then the indexes are updated after the column is updated. So let's try to drop a column, not column, but an index.
Drop the index. Okay, so I'll do drop index, I suppose. ID X number.
Yeah, and you need to specify the table as well.
Table, okay.
On
large, I think. I don't know. We'll see. Okay. So I drop the index now. I will also again do show indexes to confirm that the index is gone from large. Yeah, it's only primary key index now. And now I will copy paste this command that updates the number column. Yeah, it's at least half the time is saved.
Yeah.
It took 1.83 seconds here, and it's less than a second here.
Exactly.
So if I have a database with a lot of inserts and a lot of updates, and I'm changing like a lot of columns here and there, then I should not have too many indexes.
Exactly.
Or it will be slow.
Yeah. Yeah. And there's a balance always, like for too many or too little indexes, you will have to find it almost for its table.
Great. I think I kind of understood now what indexes are and how to create them, how to show them, how to drop them. And if I have to read more about indexes, which link would you recommend?
I think there is, apart from MySQL links, there is also the Medium link.
Okay. So I will try to just access it and then show where we can use this. So this is the official MySQL documentation, dev.mysql.com. It's a reference manual, and for every version, it's a different one. So check the version before you check the documentation. Oh yeah, I see that there is a lot of things here, like unique index, full text. If I want to read more, I can read this one, right?
Yeah, exactly.
Cool. So thanks a lot, Gina.
You're welcome.